Welcome to This Explainer. Today, we're diving into the memory black hole, exactly why you can't remember being a baby. I want you to try something a little strange for a second. Think back to an entire, incredibly rich life that you lived, but completely forgot. I'm talking about your life before you turned 3. I mean, think about it. You heard your mother's voice for the first time. You tasted actual food. You literally cracked the entire code of human language and took your very first steps. These are absolutely massive, deeply emotional moments that shaped who you are today. And yet, you remember none of it, not a single fleeting moment. Those early experiences weren't just, misplaced in the back of your mind like a pair of lost keys. They were utterly destroyed. It's essentially the ultimate neurological cold case. So what exactly wiped your early mind totally blank? For the longest time, everyone just assumed we were too young, right? Like the brain's recording machinery just wasn't plugged in yet. But the truth is actually far stranger and honestly, way more fascinating than that. Way back in 1905, Sigmund Freud became the very first person to formally put a name to this whole thing. He called it infantile amnesia. Now, there's a huge myth around infantile amnesia, which is the idea that babies just aren't capable of forming memories yet. People think their brains are just failing to hit the record button. But science has totally proven that this is completely incorrect. Your baby brain was absolutely 100% recording everything. To prove this, let's look at an incredibly elegant experiment from the 1980s by psychologist Carolyn Rovi Collier. She took these little infants and tied a soft ribbon right from their ankle to a mobile hanging above their crib. Well, the babies very quickly figured out that when they kicked, the mobile moved, and they absolutely loved it. But here is the kicker, literally. When she brought those exact same babies back, days later, they remembered. They started kicking immediately. 2-month-olds held that memory for a couple of days, and 6-month-olds, they remembered it for weeks. So infant brains can absolutely learn, store, and recall information. The real question is, where do the memories go? Well, that brings us to suspect number 1 in our biological timeline, the hippocampus. To really understand this, we need to look at the biological engine of memory. The hippocampus is this small structure deep inside your brain that acts kind of like a save button for your experiences. It takes a lived moment, say a birthday party, and encodes it so you can play it back later. But in a baby, this hardware is severely underdeveloped. There's a specific region called the dentate gyrus, which is basically the physical doorway that new memories have to pass through. And in infants, that doorway just lacks mature wiring. That whole system isn't fully connected until you're somewhere between 2 and 4 years old. So your infant brain was perfectly capable of forming short-term memories, just like those kicking babies, but it simply didn't have the physical infrastructure to transfer those memories through that doorway into permanent, long-term storage. But, structural immaturity is really only half the story. In 2014, 2 neuroscientists up in Toronto, Sheena Jocelyn and Paul Franklin, dropped a massive plot twist on this whole field. They were looking really closely at a biological process called neurogenesis. During your first few years of life, your hippocampus is just pumping out brand new neurons at an absolutely extraordinary rate to build up your permanent brain circuits. Jocelyn and Franklin proposed a hypothesis that honestly sounded almost absurd at the time. They asked, what if the very biological process building your brain is the exact same thing that's destroying your memories? Think of it this way. In an adult brain, memories are safely tagged and stored away in very stable circuits. But a baby brain is going through rapid neurogenesis, which means tons of new cells are constantly forcing their way into those existing circuits. And every single time a new neuron jams its way in there, it physically disrupts and overwrites the connections that were already laid down. And those were the very connections holding your earliest memories. So your baby brain wasn't too weak to remember, not at all. It was just a massive, chaotic construction zone. It was frantically building new rooms, and it literally had to tear down the old walls to get the job done. To prove this super counterintuitive idea, they actually ran some incredible experiments on mice. When the scientists took adult mice and artificially cranked up their neurogenesis, basically creating a baby-like explosion of new brain cells, those adult mice started completely forgetting things they had previously learned perfectly well. Their memories were literally overwritten. And then, conversely, when they artificially slowed down neurogenesis in infant mice, those little guys actually held on to their early memories much, much longer than normal. The biology here is incredibly clear. The rapid physical growth of your brain literally bulldozed your early memory circuits. But hey, biology doesn't explain everything, right? Let's escalate this mystery to an existential level. To form what scientists call an autobiographical memory, the kind of memory where you can close your eyes and vividly replay an experience with you as the main character, you require a sense of self. You have to fundamentally understand that you exist as a distinct person, totally separate from the world around you, and that these events are actually happening to you. If there is no you yet, well, you simply cannot be the main character in a memory. Developmental psychologists Mark Howe and Mary Courage really championed this missing psychological piece back in the late 1990s. We can actually track how this continuous sense of self is born through the famous rouge mirror test. It's fascinating. If you dab a little dot of rouge on a baby's nose and sit them in front of a mirror, before about 18 months old, they treat the reflection like a completely different kid. They'll wave at it, maybe try to look behind the mirror. But right around the 18-month mark, something incredible happens. They look in the mirror and they reach up to touch their own nose. Boom! That's the birth of self-recognition. And that exact moment tracks perfectly with the age when autobiographical memories finally begin to anchor in the brain. Because think about it, before you recognized yourself in that mirror, there was literally no narrator inside your head. Without that internal voice going, I am doing this, or this is happening to me, a child's experiences just cannot be packaged as personal memories. They're basically just these disjointed events happening in a void, rather than a chapter in the actual story of you. And that brings us right to our final, super crucial element, language. Developmental psychologist Catherine Nelson spent years looking into early memory, and she realized that before you can speak, your experiences are really just raw, chaotic sensory impressions. A sound, a weird texture, a bright light, a sudden rush of emotion. But language does way more than just describe our memories. It physically structures them. Without words to organize all those raw impressions, experiences are like water poured directly onto a table with no glass to hold it. They pull there vividly for a second, and then they just evaporate. Language gives your memory a skeleton to actually hang on to. And the proof for this is powerfully visible all across the globe. Dr. Chi Wang, a psychologist at Cornell, discovered that the average age of your very first memory actually shifts depending on the culture you grew up in. In Western cultures, where parents are constantly narrating their kids' lives, always asking, oh, remember when we went to the park? Earliest memories usually start around 3.5 years old. But in the Maori culture of New Zealand, which places this immense, beautiful emphasis on rich oral storytelling and detailed personal histories, their earliest memories reach all the way back to 2.5 years on average. Meanwhile, in certain East Asian cultures where early narratives focus a bit less on individual experiences, memories might not start until closer to age 4. The literal stories your parents tell you physically shape how far back your brain can reach. So looking at everything we've unpacked in this explainer, we can finally solve the cold case of the memory black hole. It wasn't just one single thing. It was everything, all happening at once. Your biological hardware, that hippocampus, just wasn't fully wired up for long-term storage yet. And the fragile memories that did manage to form, they were actively bulldozed by the rampant neurogenesis required to build your actual adult brain. Add to that, psychologically, you lacked a concrete concept of self to anchor those early experiences to, and you had zero language to give those fleeting sensory impressions a structure that could actually survive the test of time. Which leaves us with this final, beautifully provocative question to chew on. You have this massive black hole where your first years should be, but it's not because your brain was failing you. It's because it was doing something infinitely more important than remembering. It was busy becoming you. But if you had no continuous sense of self back then, and the actual biological circuits that held your early life were physically torn down and rewired beyond recognition, is the baby in your old family photos actually you? Or is it someone else entirely? Someone who happened to live in the exact same body, but whose mind had to be completely disassembled and rebuilt, neuron by neuron, just so the person watching this explainer right now could exist.